Today on my table, I do not have a MacBook. I have a Razer RZ09 something or other. It's a 6000 series Ryzen CPU 3070. It was probably a $1,500 gaming laptop when it was new. It's probably worth 12 or $1,300 now. It's still a fairly expensive machine, and this just kind of died for no good reason. I saw no signs of liquid damage. Machine's quite clean. I don't think this person did any sort of misuse. Perhaps a solar flare hit the laptop and caused some kind of electrical interference on a capacitor and made it explode, which is what I think is going on. There are no schematics. There are no board views for this. I found a BIOS dump for it. That's about it. So we don't really have a lot to work off of. But this has USB-C ports. So what I can do is I can plug in a USB-C amp meter and kind of see what it's doing. And basically what this did is we get 20 volts on the USB-C, low current. A lot of these Windows machines, you need to press the power button for them to actually go into further power states. They won't automatically turn on like a MacBook. In any case, though, you press the power button, nothing happens. This sort of, 20 volts, low current, sort of, generically tells us there's some kind of problem on a very early stage power rail. I want to pull up a power sequence diagram. So the general idea, right? Like, let's say, this is why, like, if we see a MacBook and we're getting, 5 volts, like if we're getting 6-7 watts of power, right? Wattage is just amperage times voltage, basically, right? So, 20 volts and, 0.2 amps or 5 volts and 0.4 or whatever, right? Some sort of significant voltage. Generally, you're basically getting a short circuit, like, from here and later. Like, just for example, a 16-inch A2141, a lot of times if it has a short like here, like that buck controller is shorting, you'll see 20 volts and like 0.2, 0.3 amps, like 6-7 watts. And this will just get hot. So you can just run power through USB-C and on a thermal camera see what's causing your problem, if it is a short that's causing your problem, which it generally is, right? But if we had a short on PP bus on that same machine, I would not see anything get hot through the amp meter, and I would get like 20 volts and like nothing, like 0.05 amps or something like that, right? So because when we have, you think of it as like, we have a bunch of right here, we go all the way down, really there's hundreds of lines, but right, this is like the machine's on, we're unlocked when we're in this area. Obviously we're gonna have more current here because it's not only powering this line, but it's powering everything on before it. So if this first line or this line or something is shorting, we're not going to get a lot of current because only either basically 0 lines are getting powered or a couple. So that's kind of, one of the main ways, like when you're looking at a USB-C amp meter and you see X voltage and current draw, and you can kind of get an intuitive sense of what's wrong with the thing through, experience. I'm sure there's a handful of devices where this works slightly differently, but this is a pretty good general principle that you can follow. Even like this sort of stuff. This is like a bizarre proprietary plug for the main power plug. There's also like universal charge adapters for a lot of Windows machines where you can basically have a USB-C brick and plug in a current meter, and then that cable then terminates into this, so you can still see what this is drawing for current and voltage too. So it is easier if it just has a Thunderbolt port that can run 100+ watts. I don't think I have an adapter for this. It's a pretty weird connection, but any like barrel jack Windows charger, you can generally get something like that and run it off of a USB-C. Like we just have a 240 watt USB-C Apple cable and then the Apple charge adapter. We'll use that to run USB-C power into this sort of stuff just to get an idea of what's going on with it. How do we figure this out? There's no, nothing gets hot. I don't know what anything on the board is in a very precise sense because I have no schematic, I have no board view. I've never seen this board before. So, pretty much what we did is we just kind of try to follow power around. I plug in the charger. Well, first thing I did was just look on a thermal camera just in case. I kind of, 20 volts, 0.1 amps, you're probably not going to see anything get hot. I was just checking, just in case. I didn't see anything get hot. Where we already visually inspected the board. I don't see anything. No, the ports look bad. Nothing. No hints. I kind of just plugged in power and started probing around voltages on, fuses, pretty much. checked for shorts in a few key areas. I started looking around this area. I see an ISL charging chip, intercell. I see we're getting some lines that are, you know, 5 volts, some are 3. Okay, you know, that's all well and good. You know, I checked this fuse, and then eventually I checked this fuse. I'm getting like, well, not. I got like a stable low. Let's see what this does. I don't actually 100% remember. But eventually, after measuring a bunch of shit on the board, I saw. What did I see that made me check this? Let's see. Maybe I did it for no good reason. I'm seeing on. Yeah, really, I saw a similar thing on this fuse too. I don't know. Basically, in any case, I just saw like a stable kind of lowish voltage on. Oh, I don't have my. I'll do this. Okay, right. So I just kind of saw a stable-ish low voltage, and this sort of fuse, like I see this on the board, and I'm like, oh, this is like a fuse for main or something like, you know, this is my PP bus fuse for this Razer. It's basically how I'm thinking about it. So, and then I take out power, and I just checked. I'm like, do we have a short on this? We do. I'll show you. If you don't believe me. That's probably not supposed to be that. Right, so we got like 0.2 ohms. I'm gonna take off this fuse and send voltage into this. One other thing, this is a 6000 series Ryzen board. These lines, like, these all look like they have a fucking high side Mosfet short. The natural resistance on these coils is probably supposed to be this, like 0.2, 0.3, 0.4. I've seen a lot of those like ROG Zephyrus machines, and they all kind of measure like this even when they're working. So I wonder if this is, the Ryzen chips seem to survive the high side shorts more. This doesn't have that, I don't think. We'll see. Okay, in any case, I'm going to desolder this fuse. I'm going to see which side of the fuse has a short, and we're going to shoot power into it and see if see what explodes, basically. Not explodes, gets hot. That was a joke. I'm just kidding. Just kidding. Okay. I'll put some of the flux on the fuse. It's a very yap heavy beginning of this video. Okay. We'll set that fuse aside. This fuse is actually big enough to where I won't lose it forever, so I'm just going to set it aside on my table. If it was like a real small part and I really needed it, like just for, I could probably just grab a PV bus fuse and replace this part with that. So we have a short on this side. Not this side, right? Okay. And of course, the fuse does not blow. It never blows. Fuses are just for show on laptops. We're gonna solder a wire onto here. I have my power supply at 1 volt and 5 amps. That will probably be enough to tell us what our problem is. If it's not, then we'll crank up the voltage a little bit. Then we'll kick it up a notch. Okay, that's on there. And then what we want to see on our power supply, I wonder if I can get like a good, let's think about this. If I do, power supply here, right? We have our wire on our thingy. Okay. camera. In any case, what we basically want to see here is when we connect, and we see that immediately it's drawing like 3 amps. If we didn't see this climb up, then this line probably doesn't actually have a short. Like, if we just soldered 2 wires to ground, we wouldn't really see the current climb up like this. In any case, right? You should see current climb up essentially on there. Obviously, the board's going to be a little bit warm right there because I was just shooting hot air on it. I like this in black and white mode. I'll flip this around. Oh, is this? It looks like it's something on the other side of the board. So you see something kind of, we'll go like this now. See something right about here getting hot, and it seemed like it was on the other side of the board, so turn this over. And let's look, is that like right over here? Okay. So this is totally just a fucking high side short on something. So this Mosfet, we're gonna have to order that chip. I found the chip, and blah blah blah. It's only available in China, of course. So I have to wait a long time to actually get the part that I need. But what we can do is just remove this right now. We'll see if we see a difference. Then I guess whenever I get this chip back. Looks like it's not too bad for delivery. Looks like we get it within less than 11 days. Not terrible. Probably order a couple of these. How much is 5 pieces? We'll probably just get the 5. Maybe someone else will come in with one of these and I'll use it again. Probably not. This is probably the only time I'll ever see this computer. Okay, let's remove the chip that was getting spicy. It's the second one down. Going to put some of the flux on it, and just looking at it, right, it looks fine. Who would have thunk? Okay. Okay, and I did already desolder that wire. Let's see what we get on this line now. 4 is the resistance. Now we are getting several thousand ohms. Cool. So our short's gone. Let's see if we see any difference on these coils now. Let's look right here. So actually this did go up. So it was at like 0.2 ohms. Now we're at like 1.5. These Ryzen, I'm measuring on these guys. Before we were getting like 0.2 on all of these. Now we're getting like 1.6. That's why these are kind of like weird to measure around here, because you can see like less than an ohm on these sometimes, and that's normal. It's working. This is probably better. The fact that the resistance on this is still climbed up, and it's a higher resistance than the actual short that we had. The CPU is probably okay. It's probably what happened is just 20 volts shorted into this and screwed something up, basically. The AMD CPUs seem to be more like they survive this. I almost never see the Intel ones like they just die when this sort of issue happens. High side short. They don't live to compute again. So we'll order this chip. We'll call the customer and tell them it's going to be 2 weeks till I get this part, unfortunately. But that's that's probably it. Hopefully this works. I'll be really sad if it doesn't. But I think it will. So we're going to get the chip ordered, and I guess I'll be back in a few weeks when I have the part. Okay, so we have our Mosfets from over the ocean way. It's going to take a few weeks to get here. It's kind of expected. But now hopefully we can get the new Mosfet on here. This will work and our CPU's not dead. I have higher hopes for this because it's an AMD CPU, and we did see the resistance on the coils climb. Just looking at this, I think I want to just kind of clean up the solder on a couple. We might be able to just kind of flatten this out, and that'll be fine. Really, looking at it. Okay, get some flux on there. Turn up the fume extractor to not get the cancer. Just apply some hot air heat and wick this. Let's get some leaded solder on here. Okay. Basically gonna warm up the board here just because this seems to really be soaking up a lot of heat with the pencil. Yeah, just add some leaded solder onto this first. We're gonna work with that. This is okay. I just really wanted like flatness on there, so I just added some leaded solder, hot air with the iron, just to kind of assist with the micro pencil. It's kind of hard to get a larger iron in this space. It's kind of almost like a little crevasse, as it were. Got our new buddy right here. Get some fresh flux. Okay, and on a, you never want to push down on a VGA chip, but for a QFN chip like this, it's okay. It sits flat on the board. It's not elevated on its balls. I'm basically going to clean this off now. I guess we can just see what it does maybe on a USB-C amp meter when the board cools down now. We were basically getting 20 volts and like no current before. I forget which connector's the power button on this. Generally on the Windows power states. Maybe this is on. I think I found one like power sequence diagram for like some Acer board repair that I found. I think it's when we had a video on it. It was just like a short on main with a bad capacitor. But that one did actually have a full schematic with a power sequence diagram for that machine. And we can see like the third rail to come on is just, you know, power button. So there is generally there's some setting in the BIOS that, you know, is like wake on charger or something like that. But most of the time these things won't actually go through all power stages just off the charger. You need to, you know, press the power button on the computer basically. So I mean, with a more maybe open-ended problem, you could just take the power button out of the chassis and just, you know, press it to easily turn the machine on, or you can just short the pins. Generally, any power button is just going to be, you know, just you know, positive, negative, and you short those together. And it's like when you have a, you know, desktop computer, you take a screwdriver and you short the on pin. You know, it's just shorting two pins together basically. So you can also do that with a pair of tweezers. I'll let this cool down for a second, and we'll see what it does. Okay, and we are seeing something a little bit different than the onset. I think I'm just going to put this back together and, you know, try to turn it on and see what happens now, basically. You know what we can maybe look at? This isn't certainly not turning on. We can maybe see what the correct voltage on that fuse that we removed before. Oh, and then I didn't put back on. That would probably help. So yeah, it would turn out having the DCN fuse is important. So we have a fuse on there, and this line's reading, you know, 20 volts. Before we were getting like 0.2. Our short on this line's resolved. I think we just need to press the power button to actually make the machine go into a later power stage. So it could short the pins together, but this will either work or the CPU's dead, pretty much. So I'm gonna put it back together and pray. I think this will be okay. We will see shortly. Christmas came early. The laptop survived the high side Mosfet short. I feel like these Ryzen CPUs maybe live half the time or something like that. I've had some people say that some Intel machines survive, but it's really, really rare. I think I've seen maybe one Intel machine where the CPU survives. Generally what you look for is, so you have your short circuit on your 20 volt, you measure it on the CPU inductors, whatever you get. What you want to see is when you remove the shorted MOSFET, that the resistance on that line climbs up in some significant regard. I assume the reason these Ryzen CPUs maybe survive more is the resistance to ground on that line is naturally low. So when the short occurs, the 20 volts generally doesn't go directly into the CPU. It offshoots to ground instead, or something like that. That's probably, you know, not close to exact, but I think in a practical thought that kind of makes sense to me. This laptop seems to be working. We're going to run some stress testing on it to make sure, but should be all good. And probably the next thing that we fix will be a MacBook. I have some more, a couple, I think we have a 14-inch M2 Pro and a 15-inch MacBook Air, which I haven't had those in for a board repair yet, but they're pretty similar to other machines. So, and this one, the battery was already charged up. We can see it's, you know, drawing, you know, 50 watts or something. I think the battery's at like 90-something%. So, Should be a happy Razer laptop, so this can game once again, or productivity work. I'm not exactly sure what this was being used for. Probably games. We'll see you in the next one. Hopefully your $2,000 gamer laptop doesn't die for no good reason after you've had it for a few months, because that's basically what happened to this. But it should be okay now. Lightning generally does not strike twice in the same place. We'll see you next time.